Hey, what's up, guys? This is Cheng here. So, so today let's take a look at today's daily challenge problem, number 556. Next greater element number 3. So it's like a medium problem. Okay, you're given like a positive integer n and find the smallest integer which has exactly the same digits existing in the integer n and is greater than the value itself. And if no such positive integer exists, return -1. And also another constraint is that then the return value should be fit in the 32-bit integer. If the value is greater than this 32-bit integer, we also return -1. And here we have some examples. But here I think the examples are really just two very basic one. So for example, this one, if n is 112, and in order to get the next biggest number, right? I mean, basically the only option is we have 2, 1. And for the case uh, of 21, there's no way we can get a greater number, right? By using the same integer, same like digits. That's why we return -1. Uh, yeah. So I mean, so if we only use these two examples, I think it's hard to find some patterns here. You know, let's try to find another one. Let's say we have 2, 3, 1, 0, 1, 4. Hmm. Actually, I would use this one. 5, 3, 1. How about this one? Let's say we have this number here. Okay, so if we try to calculate this test case by hand, what's going to be our answer? So I believe the answer should be 2, 3, 1, 0, and then 3, 1, 2, and 4. Yeah, I believe that's going to be the answer, right? Which is going to be the using the same number of digits, but also uh, that's greater than the previous one. Also is the smallest greater values, right? And how did we come up with this number? So basically we traverse from the end to the start. We keep traversing it until we find an index whose value is smaller than the previous one. In this case, it's number 2, right? So because if everything it's ascending, let's say if we have a 9, 8, 6, 4, 3, 2. If this is the number, obviously we're gonna return -1 because there's no way we can find a greater number than this one because everything is increasing or decreasing from the other side. That's why we're traversing from the end here, right? We have 1, we have 3, 3 is greater than 1, and we keep going. 4 is greater than 3, and then now we have 2 here. So 2 is smaller than the previous one, which is 4. Then we know, okay, so this is the place where we're gonna update, right? The reason we're traversing from the end is that since we're going to find the smallest integer, which is greater than n. That's why as long as we find the first digit from the end, which can be replaced with a potential greater digits, and that's where we're gonna do the update. And then once we find the location, right? So then what's gonna be the number we will be updating, right? So in this case, it has to be basically the smallest number, right? Basically the smallest numbers who is greater than the than this two. In this case, it's three, right? Yeah, so that's gonna be the so we'll find this three here. So I mean, the easiest way to do it is we just do another linear scan, right? We either scan it, I think we should scan it from the end. And then as long as we find the first number, right, which is greater than the current one, and then we know that's the one we're going to do the swap because this one is sorted, right? It's sorted. That's why we can just do we can sort. We can uh, search from from the end, which is smallest, and then the moment we find a number that's greater than the current one is two, then we know okay, that's the number we we'll do the swap. And this scan is going to be a linear scan. And actually another better option is that since this one is sorted, we can always use a binary search, right? So we binary search the numbers on the right side, and then we find the first element which is greater than the current one, right? And then we just use that. We just swap that index. So after swapping these two index, we have three here and we have two here. And after swapping, the second part, I mean this remaining part is also sorted. And we just need to reverse this part because we are going to get the smallest, right? And since we have already updated this digits, and that's why after updating this 2 to 3, we need to swap. Well, sorry, we need to reverse this part so that we can get the smallest uh, combinations after this 3, which is 1 to 4. So yeah, that's it. I mean, I think that's pretty basically three steps, right? So first, we we just traverse from the end, and then we find the index whose value is smaller than the previous one, and then we just try to find the uh, the first number which is greater than the current one, and then we just swap those two numbers, and then we just in the next in the end we reverse the this part. And to find the three here, we can either use like a linear scan, which is going to be the O of n, right? Or we can do the binary search, which is log n. But the total time complexity won't be changed because to find this index, the worst case scenario will be using a linear scan because this location could be somewhere at the beginning, right? So that to find the first index, we'll need O of n time. Let's say n is the length of this integer, right? And then to find the second to find the numbers that can be swapped, we can either use a linear scan, which is O(n), or a binary search, which is log n. And then we also need to reverse this part, which will also needs like O of n time. So yep, I think that's the basic intuition here. And then let's try to do the implementation. So for me, since we're going to do like a swap, that's why I'm going to convert this string, this integer to a string, and then from string I convert it to a string list, right? For C in S, so that we can do the swap later on. And then we need the length, which is the length of the S, where S list it doesn't really matter. Since we already have an N here, I'm using a L here instead of N. And then I think first thing first, we can just do L equal, if L equals to 1, right, we simply return -1, right? So if there's, here I'm checking if there's only one digit, then we just return -1 because there's no way we can get a bigger number. So that's that. And then now we're assuming we have at least two digits here, so that we can start with L -2 here, right? Since I'm going to find that position, that index that we're going to do the swap. Basically, while L is equal greater than 0 and the s dot list I is greater equal greater than s dot list I plus 1, right? And we just do a I -1. So here I'm just doing the while loop. I continue I continue move the cursor when the current one is greater than the previous, either equal or greater than the previous one, and then I move the cursor. So at this moment, we should have find the an index that we can do a swap. But if we can't, which means that if the I is smaller than 0, then it means that it's this strictly decreasing. I mean, uh, it's non-increasing case. Basically, we have 9, 8, 7, 7, 6, 5, 5, 4. So this is the case. And in this case, the I in the this at this log at this for this case, I will be -1 now at the moment. That's why I will return -1 because this will keep moving until we have reached this 0 or -1. So, and here we have find the place to swap, right? And then we just need to find the first number which is greater than the current i's number. So then I'll just use another pointer which is j. So while s list dot j is either equal or smaller than the s dot list dot I, right? And then move the j. I move the j. So here I don't have another constraint for j because I know there's always a number. There's always a number on the right of I, which is greater than the s list I. I just need to find it. So now I can just do the swap, right? So si, then s list I guess I, then swap is I and j. Okay. Now, so now the next thing is that I just need to reverse the remaining part. So I just need I plus 1 that, right, equals to reversed. I'll just use a Python helper functions, right, as list dot I this. So I do a I plus 1, right, because we have, if we have a 1 3 0 2 4 3 1. So here's I, right? Here's I, and we want, after the swap, we want to reverse this part, which is the I plus 1 to n minus 1. That's why I do a I plus 1 here. Okay. Now after this one, I mean, we have our final answer, which is I can join this this join the s list to a final string here, and then in the end, I simply just check, right? I return the integer of answer if the integer of answer is smaller than the 2 to the power of 31, which is within the 32 bit, right? Else -1. Yeah. So I think that's it. Yeah, and run the code. Yeah, there you go. I mean, yeah, so I think that's it. I mean, there isn't too much about time complexity here. I mean, if you really want to answer that question, the total length of n is going to be 31, right, in total. And here we have on here, so the time complexity will be O of n, right? That's that. Yeah, I think that's it for this problem. And it's just like a little bit of number thing where you have to find the pattern. And once you find the patterns, and how can you, and then you just do some like arrays and strings manipulations and do the reverse. And yeah, that's pretty much it is. Cool. All right. Thank you so much for watching this video, guys, and stay tuned. See you guys soon. Bye bye.